Tutor, where school is made simple. Let's go. In this video, we're going to look at how to graph a linear equation in slope-intercept form. Much like in a previous video where we looked at a map and used GPS in order to find the slope of a route, we have to know where we start, and that is always going to be the y-intercept. In this case, our y-intercept is 2, which means we start at the origin and then go 2 units up. So I'm going to start with my point here, and then I'm going to move that 2 units up. And then I have my y-intercept. Now from here, I use my slope, which is 3. Now going back to my definition of slope, which is that slope equals rise over run, then I'll start at this point and move that 3 units up. And then move it 1 unit to the right. And now that I have my beginning point and my second point, I can now construct a line through here. Now, I'm going to set this line to have some particular preferences because we're going to look at some other stuff as we go through here. So I'm going to set this to be a dashed line. Now, according to theory, this is my line y equals 3x plus 2. But what I really want to look at today is how slope works and go to the concept of rise over run. So what I've done to the left of my graph is set up a line segment called AB. And then I have a point on here which I can move around. And notice that I've broken it down into 2 parts, rise and run. According to my equation, my slope is 3, which means my rise is going to be 3 times as big as my run. And if we were to divide these numbers, we would find that the run is in fact 1/3 of the rise, or that the rise is 3 times the run. Now, once I do that, I'm now going to use this in order to translate our starting point 2. And we're going to look at how moving these points around is going to result in this line. So the first thing I'm going to do is take this point and move it by this distance, because that's going to move my point up. So I'm going to mark this as my distance, and then start here and translate my point by a fixed distance, a marked distance, and the angle is going to be 90 because it's going straight up. And then I'm going to translate this same point by the run. So I'm going to mark that as my distance, and then I'm going to translate this point by that distance. Now notice what's happening here. That I'm going up by this distance, which is similar to my run. And this is my fixed distance, which is similar to my run. Okay. If I look at these and move this point up and down, notice what happens. They form all the points on the line. And this is the concept of slope, that no matter what x and y I put in, my slope is going to remain constant as long as it's representative of this equation. So that as I animate this, you can see that all the points that follow that slope are going to be on this line when it has that starting point. And this is the foundation for a line.